The agenda of today's session, we will be seeing what is microwave, how it is evolved, where it is applied, and the advantages and disadvantages of microwave transmission. And in microwave planning process, we will be seeing how a microwave link will be planned and installation configuration of a microwave link. If you have any queries, please note it down, and we will discuss at the end of the session in Q&A session. First, we move on to introduction. Hope you all are aware what is a microwave. Microwave is a radio frequency which ranges from 1 GHz to 30 GHz, and its corresponding wavelength is 30 centimeter to 1 centimeter. And the technology which is used to transmit data using this microwave is termed as microwave transmission. And the important characteristics of a microwave are, since it is very smaller in wavelength, it's commonly used in point-to-point communication, and its high frequency is used to carry a large capacity while compared to other media. And since it is a wireless communication, it's vulnerable to atmospheric changes and rain, and it requires a line of sight without any obstacles. Now we can see how it got evolved. Some 122 years ago, a well-known scientist, Mr. Thomas Alva Edison, had spoke about wireless communication, how a wireless communication can be established. After his idea, there are numerous experiments happened on this field by well-known scientists Marconi and Tesla. Only in late part of 1940s and 1950s, the microwave transmission came into existence. And in 1960s and 70s saw a huge progress in this microwave transmission field, where it is applied. As you can see, microwave transmission is used as a transport medium in basic service networks such as TV broadcast. Hope most of us are cricket lovers, and there is a IPL 7 in progress, and we will be following. Wonder how a ball bowled in any place, that is, say for example, if it is say Eden Garden, can be seen from our television within fraction of seconds. This is due to the microwave transmission happening between the microwave antenna fixed at the stadium, which in turn send the signals to the satellite, and satellite will send the signals back to TV broadcasting channels. The next important application will be mobile cellular network. Though mobile cellular networks nowadays using fiber optic communication as their main transport medium, they are using microwave transmission as a backup in case of any fiber cuts. Still traffic can be flown. And third one is last mile access. Last mile access in the sense, if you are going to install a site at the farthest place, say for example if it's a hilly area and no other sites is going to be installed in near future, it's waste of money to lay fiber for kilometers. Instead you can go for a microwave links. It will be cost effective and will be very handy. And next is Bluetooth. Can anyone guess what is the frequency used in Bluetooth, which we are using in our day-to-day life? It's 2.45 GHz, and it's unlicensed, and anyone can use in their devices, and it is also a part of microwave spectrum. And the next point is radar. Hope everyone aware how a radar will be very useful in air traffic and army. And the last application will be DTH, direct to home, what we are using in our home and fitted in our cafeteria, Tata Sky. There are so many examples. After seeing the applications, now we can see what are the advantages and disadvantages of microwave transmission. Advantages: first is rapid deployment. It is very easier to install a microwave link, that is it takes very less time when compared to fiber optics if there is an tower exists in the location or any infrastructure is already in place. The second thing is flexibility. You can easily dismantle and reuse a microwave links when compared to a fiber optic links. And third one is easily crosses city terrains. As you all are aware how it will be hard to lay fibers through the city. In those cases, microwave link will be very useful to install towers in the city terrains, and low startup costs. It is independent of link distance, minimum recurring operational costs. It requires very less man hours to recur any operational issues when compared to fiber optics. And last is microwave links are not vulnerable to catastrophic failures like fiber optics, which can be easily failed due to cable cuts. Though we have large number of advantages on a microwave link, we have few disadvantages. We can see what are the disadvantages of a microwave link. First is atmospheric anomalies. Atmospheric anomalies means if there is any variation in atmosphere, it may affect the microwave links. Second is ground reflection and shading, excessive rain, interferences, thunderstorms, and even a very high wind can disturb the alignment of a microwave antennas. And the last is equipment failures. Microwave links have experienced more equipment failures when compared to fiber optics because they are fitted in outdoor. We have seen what is a microwave, how it is evolved, what are the advantages and disadvantages of microwave, how it is, where it is applied. We can now move on to microwave planning process. How a microwave link is planned. These are the steps involved in a microwave planning process. First is map study and field survey, link budgeting, frequency and polarization assignments, interference analysis, and final link engineering. Map study means if you are going to plan a microwave link in particular place, you can identify the Earth's nature, that is terrain of Earth, using maps which are available in markets. Say for example, if there is any 14-story building available in the line of path where you are planning your microwave link, it won't be detected in map study. In those cases, field survey will be very useful. Field survey is nothing but inspecting the site physically, where you can identify possible obstacles. The equipments which are used for field survey are GPS and altimeter. GPS, as everyone knows, GPS is global positioning system. With the help of GPS, you can locate the lat long of the particular location, and altimeter is used to measure the AMSL. AMSL means above mean sea level of the location where you are going to install the microwave link. The next point will be link budgeting. Link budgeting plays a vital role in planning a microwave link. You can see the formula written in this here. It is receiving level at B is equal to transmitting power at A side minus loss at A side plus gain at A minus free space loss plus gain at B antenna and minus loss at B side. By using this formula, you can derive what will be the receiving power you will be getting at the particular site. In earlier days, it will take more man hours and numerous calculations to derive the receiving level on link power budgeting. Thankfully, we have lots and lots of softwares available in the market now, which will give you the results within seconds once you have given the inputs. And after link budgeting, we can see what is frequency and polarization assignments. frequency in telecom field, microwave links uses the frequency 7 GHz, 15 GHz and 23 GHz. As you all know, as the frequency increases, distance will get decreased. So 23 GHz is commonly used in city terrains and 15 GHz in rural areas and 7 GHz as backbone connectivity. And polarization, there are two types of polarization used in microwave transmission in telecom field. They are horizontal polarization and vertical polarization. We can see how this polarization affects the quality of microwave link in later slides. And next is interference analysis. Interference analysis may occur due to fading. Fading is the phenomenon of attenuation of signals due to atmospheric and propagation condition is called fading. Fading can be occurred due to either refraction or reflection or atmospheric anomalies. Refraction is nothing but change in the direction of beam or wave due to the change in transmitting medium. So the microwave which has been sent from site A tend to bend once it reaches the atmosphere. This bending effect is termed as K factor. And if you see in this picture, if the K value is greater than 1, that is positive, the bending is towards the curvature of the earth, and if the K value is less than 1, it will tend to move away from the earth's curvature. What if K is equal to 1? Which means the beam doesn't undergo any refraction, it travels in straight line. And important factors which are affecting this propagation are temperature, air pressure and humidity. Next thing is reflection. Microwaves tend to get reflected on water bodies and polished earth surfaces. If you see in this figure, the wave which are sent from site A to B gets reflected through a water body. What will happen if there is reflection? So the receiver will be getting more than one signal at different time intervals. This may cause signal distortion and the link may go down. And in the case of K factor, the optimum value for establishing a microwave link is 4/3. That is K equal to 1.33 is the optimum atmospheric K value. The next type of fading is rain fading. How many of you agree this is the shape of a raindrop? You are agreeing? Anyone else? You agree? Who else not agreeing?
What I was seeing during my school days,
You are not agreeing. Can you please draw how it will be?
Can't be drawn. Can't be drawn.
It can't be drawn. Any other guesses? Okay. See, the real raindrop shape will be an elliptical shape like this, and microwave links will tend to affected by raindrops. We have seen the types of polarization in previous slides. Polarization, one is horizontal polarization and vertical polarization. The horizontal polarized waves are more attenuated or affected by the raindrops while compared to vertical polarized waves. So care should be taken or planned, like in most rain affected areas and in long distance hops, vertical polarization should be used instead of horizontal polarization. In link engineering, there is another important aspect in planning a microwave link is Fresnel zones. Fresnel zones are nothing but an elliptical beam formed between the two antennas as shown in this figure, and the middle part of this Fresnel zone will be termed as first Fresnel zone. Care should be taken that this first Fresnel zone should not get affected due to any obstacles. What will happen if there is any obstacle present in the first Fresnel zone is the microwave link could not get established, or it would go down. Say for example, if you are doing field survey and you have identified some possible obstacle which may affect your Fresnel zone, how it can be identified? There is a formula to calculate this, and they will term it as a secret formula, but every field surveyor knows this formula. It is first Fresnel zone equal to 17.3 into square root of d1 into d2 by f of d1 plus d2. Here d1 denotes the distance between site A to the place where you are standing, and d2 is the distance between the place where you are standing to the site B, and f is the frequency which you are going to install for this microwave. As I said earlier, for a clear line of sight, Fresnel zone should be clear of any obstacles. Now we have done with the planning. After you have planned your frequency, tower heights, and polarization and interference analysis, next step will be installing a microwave link. For installing a microwave link in telecom field, we will be requiring following equipments. What is an antenna, an ODU, an IF cable, an IDU, and a waveguide. You can see there are two types of installation done here. One is separate mount and direct mount. In separate mount, this antenna will be connected with the ODU through a soft waveguide. Waveguide is an hollow medium which will guide the waves from the ODU unit to the antenna. In the case of direct mount, this ODU will be directly connected to the antenna and it won't require any waveguide. Generally, this ODU is termed as radio unit in telecom field. Once you have done with the installation, this is how a alignment will be done between two sides. If you see in this picture, the beam will be having a main lobe and numerous side lobes, and there will be some back lobes also will be present in a microwave beam. Alignment should be done in such a way that main lobe of side A should be in contact with main lobe of side B. What will happen if you are going to install or do alignment with a main lobe of side A with any side lobe of side B? Even though the connection will get established and link will show as up, there will be huge possibility of the link going down for even a small rain or some drizzles. Once the installation and alignment are done, this is the configuration. Capacity configuration can be obtained as per your requirements. It might be 4 into 2 Mbps, 8 into 2 Mbps, 16 into 2 Mbps, and it may be a STM1 connectivity. And hardware configuration can be either it can be protected 1+0 or either it's protected 1+1 or unprotected 1+0. After completion of installation, I will show you how a microwave link will be configured using an Ericsson made IDU and an Ericsson software. This is how a IDE will look like. For Ericsson, this is named as MMU. MMU is nothing but modem multiplexer unit, and your laptop can be connected through a console port, and you can configure the microwave link using a software called Media Link Service Manager, shortly termed as MSM. Once you have opened the software, this is how your end will look like. There will be a MMU and a radio unit. MMU is your IDU unit and RIU is your ODU. And if you see here, this is the AM rack. Once you have inserted the MMU, it will show what type of configuration this MMU is, whether it is a 2x2 or 4x2 or 8x2. It will detect automatically. You can even configure whether it is an 1+0 or 1+1 hot standby or 1+1 working, and you can fix the frequencies which we already derived from our planning, and you can put the TX power, and there will be a term called ATPC here. ATPC is nothing but automatic transmit power control. The use of ATPC is if there is any rain in the link, the ATPC will tend to increase the TX power so that the link will not go down and it will stay stable. Once the atmosphere conditions becoming stable, it will try to reduce the TX power again. What if we are getting more receiving power rather than less receiving power? The ATPC will tend to reduce the TX power to avoid the radio unit getting failure due to high receiving power. This is how it is configured. There will be CMOS, there is a loop and transmitter test port, everything available in this software. After configuration, you will see your near end and far end also. In near end, you can able to see your indoor unit and outdoor unit, and this is far ends outdoor unit, indoor unit, and its receiving level of near end and far end, and you can even do testing on far end using this tool. Only thing you should not be doing is turning off the transmitter of the far end. If you are turning off the transmitter, the link may go down and you can't establish the connection from here. You have to go to the site, far end site, and you have to turn it on again. After the completion of the planning, installation and configuration, this is the final look of a microwave connectivity. As you all are aware that STH MUX, the E1 dropped from the STH MUX will be connected to a digital modem unit. Here we can term it as a MMU in Ericsson. This MMU will be connected to an outdoor unit, that is RAU, which in turn connected to an antenna. It will start sending the microwave link through atmosphere to the far end in line of sight, and the E1 can be dropped in the reverse manner. Okay, we have seen how the microwave link has been evolved from 1940s. What is the current trend? Though we have seen STM1 will be maximum capacity, some of the operators are trying to implement like STM2 or STM4. They are doing R&Ds with several combinations. In October 2012, Huawei came up with a solution named second generation E-band. It is considered as an backhaul for LTE. LTE is nothing but 4G, and with the use of the second generation E-band, they have successfully tested a capacity of around 2.5 Gbps, that is roughly equal to STM16. This is a remarkable achievement in microwave field, and Delora is expecting their revenue will grow by 26% between these 5 years, 2012 to 2017. And this new technology has been deployed in various countries by the operators like France Telecom, Telefonica, Telenor, and Megaport. So we have concluded this session with what is a microwave, how it is evolved, what are its uses, and where it is supplied, and how it is planned, configured, and installed, and what is the current trend on microwave transmission. If you have any queries, please